So we have here 24th question. Harshika, you can start doing 24th.
Yes, sir.
Yeah,
So 1 second, I'll be back.
yeah.
Okay, sir. Yeah.
All right. So okay, you start and then we'll see how you will do. What's your approach? Show that the right circular cone of least curved surface area. So curved surface area. Okay. I'm taking as just C. Curved surface area. I'm taking as some C. Curved surface area is least. Okay, curved surface area C is least. Least means what? Minimum. That is minimum. Okay, this is what is minimum. Okay, and what is given? Given volume has an altitude equal to root 2 times and given volume. Okay, curved surface area is least and what is given? Given
So volume is fixed.
volume is fixed. Given volume. So volume is fixed. What is that volume? Volume of right circular cone.
1/3 pi r square. Yes.
Okay, is fixed. That implies yes, this is what is fixed. V is fixed. So now curved surface area. Now what you need to prove? We need to prove that okay has this condition show that tricircular cone of least curved surface area and given volume with given volume and least curved surface area. Volume is given, then this right circular cone has least curved surface area when we need to prove when it is possible when altitude is equal to root 2 times radius of the base. This is what we need to prove. Okay, you can prove it easily. So let's take our surface area of cone pi r
L.
no 2 pi rl. No, curved surface area is what?
It's pi rl only, no?
Yeah, pi rl. Yeah, pi rl, correct. Base. Right, of the correct. Parallel. Curved surface area is parallel. So this is your cone. H R L. And L square equal to R square plus H square. Everything we have to convert to one variable.
Yes, sir. So we can take h is equal to 3v by pi r square.
Okay. First of all, what we do is when C is maximum, C is the minimum, C square is also minimum. Why we take C square? Because here we have L square. So C square equal to pi square R square L square. So first we remove R square, L square we remove because here we don't have L square is another variable. So we remove L square, that's R square plus H square. So now we can remove either R square or H square, anything we can remove because we need to find out relation between R and H. So L, we don't need L at all. That's the reason first I removed L. Then you can remove either R or H. So here anyway R square is there. So better to remove R square directly. Or even H square is also there, no problem, your wish. R square in two places, H square in one place. So whichever you want, you can remove. So what is there from this? What you get is, so here you can write that, okay, I'm doing R square and I'm doing R square equal to 3V by IH. This is what we asked. Okay. So then what you get is here, C square is nothing but now pi square, R square is what? 3V by H, pi H, into R square, 3V by pi H plus H square. So here pi cancel. So C square equal to 3 pi V. I am taking only H inside, I am taking. V I am not taking inside, H only I am taking. 3V by pi H square plus, see here, H if I take 3V by H square and then this is H. So now differentiate. This you assume as function in, okay, let C square is f of H. So now f dash of H is what? 3 pi V into, here 1 by H square is minus 2 by H cube. 3V by pi if you keep aside, minus 2 by H cube plus 1. This you have to equate to 0. F dash of H equal to 0 implies this is 0. So then what you get? This is anyway 0. Minus 6V by pi H cube. Okay? Minus 6V by pi H. So this is what? Plus 1 is 0. So that will give you what, 6V equal to pi H cube. But V is what we know. V is 1 by 3 pi r square H. That implies 6V. So is 6 into V is 1 by 3 pi r square H equal to pi H cube. Like this we have to do. 2. Here H cancel. Pi cancel. So you got it now, you see. H square equal to, you got 2r square. That means what? H equal to root 2r. Okay, just by substituting this, okay, double differentiation you should do. Now, f double dash of H is what? 3 pi V, if you keep aside, minus 2 minus 1 by H cube ka minus 3 by H power 4. Into 1 by H cube ka minus 3 by H power 4. Okay, so this is positive. Negative into negative, positive, greater than 0. That implies what? F of H equal to what is that? C. Is least. Greater than means what? Minimum or least. When H equal to whatever. H equal to actually this one. H equal to this thing, but H equal to root 2r. Same thing.
Yes.
So this is semi-vertical angle. So what we need to show?
What that is, I don't understand. Can you repeat what a semi-vertical angle is? I didn't understand.
Yeah, this one is vertical angle. See, this is a cone, right? In this cone,
Yeah.
cone.
Yeah.
This is vertical angle, right?
Yes.
This is
Right.
semi. Half of this is semi. Vertical.
Okay.
Half of that is semi.
Okay.
So here this is total vertical angle and the semi means half of that. So if you obviously know this is H shape. So these both are equal only. Na? This is theta, this is also theta. Right? This is 90 degrees because 90 is R and this is L. Okay, then what is saying angle? Okay, semi-vertical angle of maximum cone of maximum volume. Okay, volume is maximum. Okay, volume is maximum. Maximum volume, if it has maximum value and of the given slant height. Okay, volume is maximum and slant height. Slant height. What is slant height? What is slant height here?
L.
Slant height L is given. L is given. That means what? L is fixed. That means what? L square. L equal to square root of R square plus H square. This is what is constant. Okay, this is what is constant. So now volume is maximum implies, now this is what is given and volume is maximum implies what we need to show? Prove that vertical angle theta equals to tan inverse root x. Okay?
Yes, sir.
What is your tan theta? Can you tell me what is tan theta here in this diagram? What is tan theta? Tell me what is tan theta in this diagram.
R by H.
Very good. R by H. That's it. That means what you need to find out relation between R and H. Already we did this, right? So R by H, for example, you get now R equal to root 2 H. So HH gets cancelled. So tan theta is root 2. That's it, over. Got it? So therefore, now let's take volume. So what is volume? Volume of the cone, you know. Volume of right circular cone. So this cone means right circular cone. 1 by 3 pi R square H. So now this volume is maximum, but you should know how you should use this one. L square is constant equal to R square plus H square. So what we should do next?
So write in terms of one variable. So
Oh, good. So
we can take R square is equal to H square minus L square, or H square is equal to L square minus R square.
where is H square here?
Sorry, sir. R square is equal to L square minus H square.
Yeah, good. Because here we have R square. Already we have R square. Better to remove R square and write in terms of L square because L square is on. So anyway constant. Okay, this is anyway constant. So R square is L square minus H square. So now this one is volume. So volume you take as let. Volume is f of h, function h. So pi by 3 is constant, keep I said, and L square h minus h cube. F dash of x, if f dash of h is what? Pi by 3 into L square minus 3h square. Okay, now f dash of h is 0. And that means L square minus 3h square is 0. That means what? 3h square equal to L square. That implies what? But we don't want relation between L square and h square, but we want h square and r square. So L square is what? R square plus h square. That implies what? 2h square equal to r square. That implies what? R equal to root 2h. This is what is the relation. Now, second derivative. F double dash of h is what? Pi by 3 into 0 minus 6h, which is less than 0. That implies what? F of h. That is what V is. Minimum or maximum. Maximum. V is maximum because less than 0. If double dash is less than 0, that means what? F of h is, that is volume is maximum when R equal to root 2h. Or what? Or this R by h equal to root 2. That implies what is R by H? R by H is tan theta. Root 2. Where theta is semi-vertical angle. You have to show in the diagram, then it will be clear. Okay, where theta is semi-vertical angle, then done. Not much difficult because already you did. Is that okay?
Yes, sir.
So, all right. Meryl, did you finish?
Yes, sir.
So let's go for 26. So, would you like to finish it or shall we do together? What would you do? Meryl, what shall we do?
Sir, anything is fine.
You should choose. The only two options we have. Shall we do right now or you want
Sir,
to?
it's very similar, right? So I guess it's fine.
Shall we do it now? What? Shall we do it now?
Yes. Sure, sure, sir. Sure. Yeah.
Okay, then we can do it quickly. Not a problem. So, little different. Show that semi-vertical angle of the right circle cone of given surface area. Now, what is surface area of the cone? Given surface area, right? And maximum volume. So here also same. So here also volume is maximum. Volume, let's say volume V is maximum. Implies what you need to prove? Maximum. What you need to prove? Semi-vertical angle. So semi-vertical angle is sine inverse 1 by 2. And what is given? Given that surface area, given that surface, given surface area. Yes, surface area. What is that surface area? Given, yes. And S equal to what? You know, pi RL into pi RL plus pi R square. So, yeah, pi RL plus pi R square. So we say this one pi R into R plus. Pi R into R plus is what we say. This is what is given. Okay, again, once again, we draw this. This semi-vertical angle, this what is theta. Semi-vertical angle, let's take this as some theta. That's what we need to show. So this is what is given, and then we'll go for volume. Volume of the cone 1 by 3 pi r square h. So here h r l and l square plus r, and we know l square equal to r square plus h square. So we have to convert everything into one variable. So what is that one variable? One variable, let's take as here. What we take is, so here sine theta is what? Sine theta is what we want. Sine theta is what? Right?
R by L.
It's R by L. Good. So H is not required for us. So first thing is that we remove of H. We need relation between R and L. So we remove H. That's a good idea actually. But anyway, to remove H, we need to square on both sides. You know, if you remove H square, then what you get is you get relation between L and then you can convert everything into L also. V square. So when V is maximum, V square is also maximum. So pi square by 9 R power 4 H square. Okay, H square I'm writing as L square minus R square. So now you can remove what? L square you can remove also. L square you can remove. This makes it complicated. Okay, anyway, it has to be complicated, or it will be complicated. Or you can remove R square. If you remove R square, then you get L square and H square. That's also okay. L square minus H square, and then L square minus H square, and here also you can remove R. Here also you can remove R. L square minus H square, and then here also you can remove R. That's also okay. Okay. But anyway, so not a problem. But here we remove. Now we need to what? Remove what? Either L square or R square. So, but L square is here, so we are removing L square. Pi square by 9 R to the power 4. Here, what is L square? Oh, L square is now we have to square. No? So, yes, equal S minus I R square by I R is what we have. So here we take R to the power of 4 inside, R power 4 into L square. L square is what? S minus pi R square by pi square R square. Okay, this numerator also whole square. Minus R to the power of 6 into S minus pi R square whole square by pi square R square. So I am thinking this is a little complicated. So V square equal to what you get is pi square by 9 is outside. Inside is R square gets cancelled. So R square by pi square into S minus pi R square whole square. Okay, and minus R to the power of 4 by pi square. Yeah, anyway, pi square is, you can cancel out. Pi square common, you can cancel out. That's better. Pi square cancel out. So then what here minus R to the power of 4 into S minus pi R square whole square. Okay, S minus pi R square is common actually. So V square equal to, you get here 1 by 9 into S minus pi R square whole square into R square minus R to the power of 4 like this. Why did I do this? Because anyway you need to do here UV you need to do, UV you need to do. Yeah, yeah, little complicated. Calculation is complicated because your surface area is cone of given surface. Surface area is pi RL plus pi R square. Here you need to, yeah, here involves little calculation. That's the thing here. Yeah, because volume is 1 by 3 pi R square H. This is R square and H, and this is RL. It means what? First you have to this. So these are three variables. You have to remove three variables and put it in one variable with the help of S. So that's the difficulty. That is the reason we got all this. But anyway, this you assume as f of r function in R. Or directly you can do this d by dv square by dr you can do, or f dash of r you can do. What? So u dash I r square into this minus 2 pi r. This is u dash v r square minus r to the power of 4. Okay, this is u dash v plus u. This is u v dash 2r minus 4r3. My God, this one you have to make 0, but you have to find out double dash also. If you equate to 0, what will happen? Or f dash of r I'll write again so that it will be easy. F dash of r I'll write again. What is that? 1 by 9 is common, and also s minus pi r square. This is also common. So 1 by 9 is common, s minus pi r square is common. And what else is common? R square also comes common actually. Here also an r, here also an r. So that also comes common, but I am not writing that. So here we write this is common. 2 is 1 by 9 is common here. 1 by 9 into s minus pi r square is common. So twice. Here also you have twice. So but anyway, I'm not taking twice common. If twice also take common. What is left, you know? So twice 2 by 9 is common. S minus pi r square is common. So minus 2 pi r into r square minus r for 4. So r you take this, r you better you take inside. But so here 2 is common, understanding this 2 is common. So less 2 by 9 is common. S minus pi r square.